Okay, let's talk about the first review for trigonometry for our first trig test. These first few statements here are things that you need to know in order to be successful on the test. Going down through the review, I'm going to work some problems. I'm going to maybe on some of the problems I will begin to work them and won't work them all the way through, and maybe some of them I will. It's up to you to take this and do what you can with it. This first part here, there's no directions that say anything here with number one. So what I want you to do here is make sure that you take the definitions from note card 4 for all the 6 trig functions and put them on here. What I'm talking about is the ratios involving y, x, and r. Okay, and you can just transcribe that from note card 4 onto this. Going down to number 2, it says sketch the reference triangle, and then it says evaluate sine, cosine, tangent, cosecant, secant, cotangent. So what we're going to do here is we're going to sketch this reference triangle, and then we're going to list all 6 trig functions, and it tells us the terminal side of theta goes through this point. So we have this point, -6, -2, which is going to, that point -6. Let me start over here. So your point is -6, -2, and so we have this triangle. This is the right angle, and so the x value is -6, the y value is -2, and we need to find r. R is always going to be positive, and so we have x squared plus y squared equals r squared. So -6 squared, when it's negative, you got to put that negative in parentheses. Don't just plug in -6 and square it in your calculator. It's going to tell you it's -36, and it's wrong. It's -6 squared. -6 squared, all with the negative included, that's -6 times -6, so that's positive 36. So it's -6 squared plus -2 squared is equal to r squared. So 36 plus 4 is equal to r squared. 40 is equal to r squared, and when I take the square root, r is equal to plus or minus root 40. This root 40 can be simplified. Remember, we do not want decimals, but we want simplified radicals. I can have 2 numbers that multiply together to get 40 is 4 times 10. So we have square root of 4 times 10. The square root of 4 is 2. So the 2 comes out, and that gives us 2 root 10. And it's plus or minus, but r is always positive. So r is going to be 2 root 10. Now all I have to do, and I'm not going to do it for you, is look at note card 4 and look at the ratio of sine. Sine is going to be y over r. So sine theta is y over r, which is going to be -2 over 2 root 10. You can't have radicals on bottom. Let me rewrite this over here where I have more room. So I want to multiply this by root 10 over root 10. Now with this one, it's a little bit easier if you cancel these 2's first, because 2 over 2 becomes 1, so essentially they kind of cancel each other out. So you really have -1 times root 10 is -root 10 over root 10 times root 10 is 10, and so sine theta is root 10 over 10, and you're going to need to find those all 6. Sine, cosine, tangent, cosecant, secant, and cotangent. If you need any help with doing that, go back to your note cards or go back to previous podcasts, but I don't have time in this review to do all 6. But it's just a matter of going to note card 4 and looking at the rules that I give you. Sine is y over r, cosine is x over r, tangent is y over x. The other 3 are the reciprocal of those. Once you find the first 3, you just flip them for the reciprocals and make sure you don't have radicals on bottom. That's all you have to do for that problem. Continuing on. Part B is another example of that problem. You're just going to do the same thing here. You're going to sketch this reference angle with terminal side going through this point, and then you're going to find the 6 trig function. So it's the same thing. Looks like we have 2 number 2's. So the second number 2 says sine theta is -1/2. Theta is in the quadrant 3. Find tangent theta and cosine theta. So we're looking for tangent theta and cosine theta. Tells me I'm in quadrant 3, so that's where my reference triangle is going to go. There's the right angle. And it tells me that sine theta is -1/2. Well, again, from note card 4, we know that sine theta is y over r. That tells me that y is going to be 1 and r is going to be 2. However, this is negative here. Since this fraction is negative, that tells me one of those values, y or r, is negative. You should know for 2 reasons that y is the value that's negative. It's going to be -1. The first reason you know that is because we're in the 3rd quadrant and the y value in the 3rd quadrant is negative. And the second reason you should know that y is negative is I've already told you that r is going to be positive all the time. So y is -1, r is 2. So now I'm just going to find what x is using Pythagorean theorem. And you need to show your work on every problem you do. Because when you don't show your work, if you can do certain problems in your head, that's fine and dandy. You're a smart person. But the problems get harder, and if you don't have the processes down, you will make mistakes trying to do things in your head when the problems get harder. This becomes x squared plus y squared is equal to r squared. So x squared plus 1 is equal to 4. Subtract 1 from each side, you get x squared is equal to 3. Take the square root and you get x is equal to plus or minus square root 3. And again, because we're in the 3rd quadrant, x is negative, so it's the negative version there. It's -√3. And now using note card 4 and those ratios involving x, y, and r, you can find what tangent theta is and what cosine theta is. And I'm going to leave you to that. Problem 3 says secant theta is -5/4. I wouldn't worry about these parentheses here. It's not necessary. And tangent theta is -3/4. So it says find the quadrant for theta and the values of the other 4 trig functions and sketch the reference triangle. We have to find what quadrant it's in based on these signs SIGN, positive or negative. So remember, all students take calculus. So in which quadrants is secant negative? Well, secant is the reciprocal of cosine. So it's going to be negative where cosine is negative. So cosine is negative in quadrants 2 and quadrants 3. Okay? And now I have another requirement I have to make here. We also, it says and, where is tangent negative? And tangent is negative here and here. We want the one that fulfills both requirements, and that's quadrant 2. I'm going to be in quadrant 2 here. So my reference triangle is up here in quadrant 2. Looks something like that. Sorry, my line's not that straight. So what we have here, okay, so I'm in quadrant 2, and I know that secant, let me rewrite this. secant theta is negative 5 over 4. And so since secant is the reciprocal of cosine, and cosine theta is x over r, that means that I have r because secant is going to be r over x, so r is 5 and x is 4. But since r is always positive, that means that this is 5, that's r, and the x is going to be negative. So x is negative 4. Okay? So I'll say that again. Secant theta is the reciprocal of cosine theta. And cosine theta, according to note card 4, is x over r. Okay? So that means that secant is going to be r over x. So r is 5, x is 4. But since r is positive, and we're in quadrant 2, x is negative 4. So we would find y. We could use Pythagorean theorem here to find y, but they give us another clue. We don't need to do the Pythagorean theorem here, because we know that tangent is y over x. Tangent theta is y over x. That means that y is 3 and x is 4, and we already know that x is negative 4, so y is positive 3. And now I can find those other values that it's asking me for because I have x, y, and r. So when they give you one trig function, you're going to have to use Pythagorean theorem to find the missing value. When they give you two, most likely you will not have to do that, and you just have to fill in, just find the values using this information. Continuing on, number 4 says tell the quadrant of the angle and if the following is positive or negative. You will use all students take calculus, and you will use your ideas and properties of how to find these angles like this. Part A. Cosine 167. Remember that if you are going in a clockwise fashion, counterclockwise fashion this way, this is counterclockwise. These are positive angles. And if you're going in a clockwise fashion, these are negative angles. So this is a positive 167, so I'm going to go counterclockwise up to, from the x-axis to here is 90 degrees. And I know that all the way over here is 180, so I'm somewhere in the second quadrant. So which quadrant is it in? 2. And then using my all students take calculus, is cosine positive or negative in quadrant 2? It's negative. Cosine is negative in quadrant 2 because sine and its reciprocal are the only two that's positive. That's how you do those questions. A, B, C, and D. Number 5, change 145 degrees to radians. Multiply it by pi over 180. Simple conversion. Use your note cards. Same with number 6. Change 5 pi over 3 to degrees. Substitute 180 for pi and simplify. Okay, no decimals. Number 7, tell in which quadrant angle theta lies. This is just like the example we did above, where I used the green and the red highlighters. A says, where is cosine greater than 0? It means where is it positive, and where is tangent negative, because it says less than 0, so where's tangent negative? Well, if I'm using all and this angle doesn't apply here, I'm just using this quadrant, this coordinate plane. All students take calculus. Where is cosine negative? Cosine is going to be negative everywhere it's not positive, and it's positive in the first quadrant and the fourth quadrant. So cosine's negative here and here. Where's tangent negative? Tangent is going to be negative here and here. So which two, this quadrant 2 fulfills both requirements. So the answer, tell which quadrant angle theta lies in, quadrant 2. You do that for all of those, using all students take calculus. Continuing on. Okay, I know you're all sitting there saying, Mr. Denny, this is positive. I thought I wrote a positive here somewhere. I think I might have made a mistake. Let's look at this again. Take a look at this problem one more time. And if the student that just corrected me is wrong, they get a 0 on the test tomorrow. Okay, we're looking for where cosine is positive, okay, and we're looking for where tangent is negative. So all students take calculus. So cosine is positive. Okay, yeah, I was wrong. Cosine is positive in the first quadrant and in the second quadrant. And now I'm looking for where is tangent negative. Tangent is going to be negative in the second quadrant and in the fourth quadrant. So the correct answer is quadrant 4. See, the truth is I really did that on purpose to make sure that you're paying attention out there in TV land and to make sure that you know what you're doing. It's a way of assessing you right there. It's pretty talented of myself, if I do say so myself. Moving on. Number 8, tell if the following are positive or negative based on the angle. No calculator. This is the same thing. We're going to find the sine of 125 degrees using all students take calculus. Sine 125 degrees is going to fall within quadrant 2. Sine is positive in quadrant 2. So the answer is that's positive. Number 9, sketch the angle. Here's my coordinate plane. It's negative. I'm going in this direction. One time around, that's 360. And I just keep going until I find 567. Okay? If I go 90 more from 360, that's 450. If I go 90 more from 450, that's going to be 540. And I need 27 more, so it's going to put me up here in quadrant 2. And that's how that works. Number 10, find the coterminal angle of these. These were most missed on the quiz. What we want to do here is if I have 25 degrees, it says 4 clockwise rotations. Okay, clockwise this way are negative angles. So I'm subtracting 4 revolutions of 360. And that's how you get that answer. Another way to look at it geometrically is if my angle is 25 degrees, I'm starting here in standard position, I end over here, then I want to take my new angle from this side and go 4 times 1, 2, 3, 4, and what is that angle? This is probably the easiest way to do that problem, but either way gets you the right answer. Okay? Part B and C, we're doing the same thing, except we want this coterminal angle to be between 0 and 360 for both of these. What you have to do here for this one, am I going to add or subtract from 765 to get in between here? Well, hopefully it's obvious that we're going to subtract multiples of 360. You may have to do it twice. If I subtract 360 once, that gets me to 405. So I've got to do that again to get in between 0 and 360. So I'm going to subtract 360 again. And that's going to put me down, looks like 45 degrees. And hopefully I did that right. That's my answer. When I say hopefully I did that right, hopefully my subtraction is right. With part C, I'm at negative 128. How am I going to get between 0 and 360? I've got to add 360. The thing here is, the key here is that we're either subtracting or adding multiples of 360. Because in order to be coterminal with an angle, they have to share the same ending or terminal side. And in order to do that, you have to go 360 degrees around, either positive or negative. Use the unit circle. Number 12. You will be able to use your unit circle on your test tomorrow. The x-coordinate is cosine theta. The y-coordinate is sine theta. And tangent is sine theta divided by cosine theta. And so these are easy. You go around the unit circle. You find the angle 240 degrees, and the y value that's associated with that is sine theta. Okay? Just like we've been doing. And finally, for number 13, some of you were probably confused by this. If you look at this in this way, now you can find the note card that shows the sign changes and tell whether they're positive or negative. They're all positive here in first quadrant. Over here, only sign is positive, and go the other way around there. Very easy. You can be done with that in 15 seconds. Study the review. These are the things you need to know to be successful on the test. You will be able to use the unit circle. No calculator.